Sine of angle theta is always opposite by adjacent side. It does not depends on the sides of the triangle, it always directly depends on the angles of a triangle here. So when hypotenuse is divided by any other two sides, obviously the value can never be less than 1, it has to be greater than 1. The sine theta and cos theta of an angle can never be greater than 1. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to learn about the trigonometric ratios. So in this session, we are going to learn about all 6 ratios whenever a right angle triangle is formed. Now consider a right angle triangle here. So let this be an angle theta. So for an angle theta, this is said to be an opposite side. And this is the adjacent side, this is the hypotenuse. So the first trigonometric ratio is sine theta. Sine theta is always the ratio between the opposite side and the hypotenuse. The second ratio is cosine and shortly termed as cos. So cos of theta is always adjacent side by hypotenuse. The next one is tan or tangent. So tangent of theta is always opposite divided by adjacent side. The next 3 trigonometric ratio or cosecant theta, so which is shortly termed as cosec theta. It is hypotenuse divided by opposite side. Next we have secant theta. Secant theta is hypotenuse divided by adjacent side. And the last trigonometric ratio is cot theta or cotangent of angle theta, which is adjacent side divided by opposite side. So all these are in terms of ratio and hence they are called as trigonometric ratios. So based on 3 sides, we will be having 6 fraction and all these 6 fraction is related to one trigonometric function. So that is sine, cosine, tangent, cotangent, secant and cosecant. So these are all the 6 trigonometric ratios. So by this definition, the trigonometric ratios and their values are unaltered. It does not depend on the sides of the triangle. It always directly depends on the angles of a triangle here. So now by looking these 6 trigonometric observation, we have the following point. The sine theta and cos theta of an angle can never be greater than 1 because we know that the hypotenuse is the maximum length and the other two are less than the hypotenuse. Now, since hypotenuse is the greater value, in sine and cosine function, hypotenuse is in the denominator. So, which is the greater value? Obviously, the ratio of these two must be less than 1. Now, the next point is the cosecant and secant theta of an angle can never be less than 1 because hypotenuse is in the numerator whose value is greater than the other two sides. So, when hypotenuse is divided by any other two sides, obviously the value can never be less than 1. It has to be greater than 1. And tan and cot theta, if the tan theta and cot theta of an angle may have any numerical value depending upon whether opposite side is greater than adjacent side or adjacent side greater than opposite side. So depending upon the sides of these two ratios, tan theta and cotangent theta or cot theta can have any values between minus infinity to plus infinity. Now if I express the right angle triangle in terms of ABC. So let me consider this as an angle theta, X, Y and R. Now sine theta is nothing but opposite side by hypotenuse, that is AB divided by AC, which is equal to Y by R. Similarly, cos theta can be written as X by R. Tan theta can be written as Y by X. Cot theta can be written as X by Y. Secant theta can be written as R by X. And cosecant theta can be written as r by y. Now, let me consider sine and cosecant. So, here sine theta is y by r and cosecant theta is r by y. So, which can also be written as 1 divided by y by r. So, which is 1 by sine theta. So, or we can write sine theta into cosecant theta is equal to 1, or we can say sine and cosecant are reciprocal to each other. Similarly, if you observe cos theta and secant theta, they also forms the reciprocal ratios. So therefore, we can also write cos theta into secant theta is equal to 1. Similarly, we can write tan theta into cot theta is equal to 1 because the ratio of them are reciprocal to each other. Whereas tan is y by x, cot is x by y. So these are the reciprocal relation between sine, cosecant, cos, secant, tan, cot. So wherever it is necessary, instead of sine we can write 1 by cosecant. Instead of cosecant we can write 1 by sine depending upon the relations. Some of the important basic identities in trigonometric ratios is you have to learn this. The very first one is sine square theta plus cos square theta is equal to 1. You can observe here sine theta is y by r, cos theta is x by r. So if we substitute here, then it is y square by r square plus x square by r square. So which is equal to x square plus y square by r square. Now I consider a right angle triangle like this with theta, x, y, r. From Pythagoras theorem, we know that x square plus y square is equal to r square. So if I substitute here, then this becomes r square by r square, which get cancels, and that is equal to 1. So this is the first basic identity of a trigonometric ratio. Sine square theta plus cos square theta is equal to 1. Now we can also convert this sine square theta as 1 minus cos square theta or cos square theta as 1 minus sine square theta. So we can interchange the basic identities. Other than this, we also have one more identity, that is 1 plus tan square theta is equal to secant square theta. So wherever it is necessary, we can change. So secant square theta minus 1 can be written as tan square theta, or secant square theta minus tan square theta is equal to 1. Similarly, the very important third identity is 1 plus cot square theta is equal to cosecant square theta. We can prove this by using the triangle. Now this can also be interchanged as cosecant square theta minus 1 can be written as cot square theta, or cosecant square theta minus cot square theta can be written as 1. So these are the, just interchanging the right hand side and left hand side values, we can get the identities here. So the three basic identities are, the first one, sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to secant square theta. 1 plus cot square theta is equal to cosecant square theta. So now you need to remember all the 6 trigonometric ratios, their reciprocal relation and the basic identities. So let us take few problems related to these trigonometric ratios. If sine theta is equal to 3 by 5 and theta is acute, then find all the other trigonometric functions of theta. So can we find all the trigonometric ratios if I know one trigonometric function? Yes. So clearly they have given sine theta is equal to 3 by 5. So what is sine theta? Sine theta is opposite by hypotenuse. They have given the value as 3 by 5. So therefore opposite to angle is 3, hypotenuse is 5. Using Pythagoras theorem, we can get this as 4. So that is, it is equal to 5 square minus 3 square, which is 25 minus 9, 16, and square root of 16, you will get it as 4 because it is a length. Now we have adjacent side as 4. Let us write the remaining. Cos theta is adjacent side by hypotenuse. So therefore 4 by 5. Tan theta is opposite side by adjacent, 3 by 4. cot is reciprocal to tan, secant is reciprocal to cos, cosecant is reciprocal to sine. We can just interchange the values or we can use the general ratio formula. Next question. If secant A is equal to 13 by 12 and A is an acute angle, then find sine A plus cos A. Again, they have given secant A. So, secant A means, so let me consider this angle as A. So, secant is hypotenuse divided by adjacent. So, they have given the value of hypotenuse as 13 and adjacent side as 12. So, we need this. Obviously, this is 13 square minus 12 square using Pythagoras theorem. So, which is 169 minus 144, which is equal to 25. So, therefore, square root of 25 will be equal to 5. So, this will be equal to 5, which is our opposite side. Now, we need sine A plus cos A. So, what is sine A? Opposite by hypotenuse. So, 5 by 13. What is cos A? Adjacent side by hypotenuse. Now, since the denominator is same, it is a common denominator. 12 plus 5 is equal to 17. So, the value is 17 by 13. Next question. If x is equal to a cos theta, y is equal to b cos theta, then prove that x square plus y square is equal to a square. So, let me consider the left hand side here, LHS. Now, x square means you need to square this. It is a square cos square theta. So, nowhere you should write this as cos theta square. So, this is wrong. So, we are squaring the function, not theta. So, we are squaring cos 2 times. Cos into cos becomes cos square. So, next we have a square sine square theta. I can take a square common, then I will get cos square theta plus sine square theta. From the first basic identity, we know that sine square theta plus cos square theta value is 1. So, a square into 1 becomes a square. That is the right hand side, hence proved. Next one, prove the following. Tan A into cosecant A into cos A is equal to 1. So, let me consider the LHS. So, tan A can be written as sin A by cos A into cosecant A can be written as 1 by sin A using reciprocal relation because cosecant and sine are reciprocal to each other. Cos A can be written as it is. So, tan A can also be written as sin A by cos A. Remember, so this is one more identity. Tan A can be written as sin A by cos A. And cot A can be written as cos A by sin A. Because sin A is y by r, cos A is x by r. When it cancels, we will get it as y by x, which is opposite by adjacent. And opposite by adjacent is nothing but our tan. Similarly, when we take the reciprocal of this, it becomes cot. So, this is also 2 important observations in solving trigonometric ratios. Now, we can cancel all the terms here. So, the value left is 1, which is our right hand side. Next question. Secant square A minus 1 into cot square A is equal to 1. Let me consider the LHS. So, we know that 1 plus tan square theta is equal to secant square theta, and secant square theta minus 1 can be written as tan square theta. So, instead of theta, we have A here. So, I can write secant square A minus 1 as tan square A. And we know that cot is reciprocal of tan. So, therefore, cot square can be written as 1 by tan square. So, which get cancels and the value is 1. Next one. Sin square theta into secant square theta is equal to secant square theta minus 1. So, let me solve the LHS and RHS separately. Sin square theta can be written as it is, whereas secant is reciprocal of cos. So, secant is 1 by cos, secant square can be written as 1 by cos square. So here it becomes sin square theta by cos square theta. We know that tan A can be written as sin A by cos A. So when you square them, obviously this becomes tan square. So this can be written as tan square A. And tan square A is the left hand side value. Again RHS secant square theta minus 1 is nothing but tan square theta. So from both, so this is instead of A we can write theta. From both LHS equal to RHS. Next one. Prove that secant A minus cos A is equal to tan A into sin A. So secant A can be written as 1 by cos A minus cos A. And taking the fractions, taking the difference, we'll get 1 minus cos square A divided by cos A. Using the trigonometric identity, we know sin square theta plus cos square theta is equal to 1. And if you want sin square, it can be written as 1 minus cos square. So therefore, 1 minus cos square A can be written as sin square A divided by cos A. And sin square can be separated as sin A into sin A divided by cos A. Now sin A by cos A can be taken as tan with sin A. So therefore this is tan A into sin A. Next one. Prove that tan square A plus secant square B is equal to secant square A plus tan square B. So consider the left hand side. Tan square A can be written as secant square A minus 1. And secant square B can be written as 1 plus tan square B. So using the identity 1 plus tan square can be written as secant square. So just rearranging these terms, secant square can be written as 1 plus tan square and tan square can be written as secant square minus 1. Minus 1 plus 1 cancels. So we are left with secant square A plus tan square B. Next question. 1 divided by secant A plus tan A is equal to secant A minus tan A. Now here, let me consider the left hand side. So we have 1 divided by secant A plus tan A. So I'll rationalize the denominator by taking the conjugate of this term. So conjugate will be secant A minus tan A divided by secant A minus tan A. Now numerator is multiplied with 1, so it remains the same, secant A minus tan A. Denominator is in the form of A plus B, A minus B, which can be written as A square minus B square. So this becomes secant square A minus tan square A. What is the value of secant square A minus tan square A? When tan square A comes here, the value is equal to 1. So therefore, this is equal to 1 and hence the remaining value is secant A minus tan A, which is the right hand side. Next question. 1 plus cot A whole square plus 1 minus cot A whole square is equal to 2 cosecant square A. Now let me consider the left hand side. Let's use A plus B whole square and A minus B whole square formula. Then this becomes 1 square plus cot square A plus 2 cot A. And this 1 square plus cot square A minus 2 cot A. So plus 2 cot A minus 2 cot A get cancels. So we are left with 2 times 1 plus cot square A. So what is 1 plus cot square A? The third identity, which is cosecant square A. So which is the right hand side. So in today's session, we have learned all the trigonometric ratios, the reciprocal relation and some of the basic identity, which helps us to solve many problems in trigonometry. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.